Hello students. So today we will be discussing the CBSE board grade 10, the first chapter, real numbers. This is going to be the part 4 video. So I have already discussed 3 videos earlier, part 1, part 2 and part 3. If you haven't watched yet, so please watch it first, then come back to this video. Otherwise you will not be able to understand what we are doing. Okay, so let's look into it, what we'll be covering in this video. So the first question is, show that any positive odd integer is in of the form 4q plus 1 or 4q plus 3, where q is some integer. So this type of question we have already covered in the previous videos. So if you haven't watched it, so please watch it. Otherwise, whatever we'll be doing here will not be able to understand. Okay. So the same way we will be considered over here, that let us start with taking a where a is a positive odd integer. Okay, because here they are asking for positive odd integer. So now we are going to apply the Euclid's division algorithm with a, and since here 4q plus 1 and 4q plus 3 they have asked to prove, so we will going to consider the b as 4 because we know that a equal to bq plus r, that is the Euclid's division algorithm. So now by Euclid's division algorithm, a equal to 4q plus r, where 0 less than equal to r less than 4. So since 0 less than equal to r less than 4, so what will be the possible remainders? That is 0, 1, 2, 3. Now a equal to 4q plus r. So if we replace the r with these possible values, then a can be 4q plus 0, that is 4q, 4q plus 1, or 4q plus 2, or 4q plus 3. Okay, where q is the quotient. Now in this case, since a is odd, so a cannot be 4q or 4q plus 2. Let me tell you why. Because you know that 4 is an even number, right? So any even number multiplied by with a number always will be even. So that's why 4q will be always even. So we have to discuss this 4q because here they are asking for to find out the positive odd integer. Now similarly 4q plus 2, since 4q is even, so if we are adding any even number to a even, that will always be a even. So 4q plus 2 will be always even, right? So that's why we have to discard these two values. So therefore the other two will be remaining. So therefore we can say that any odd integer is of the form 4q plus 1 or 4q plus 3. Now the next question is, show that n square minus 1 is divisible by 8 if n is an odd positive integer. Now let a be any positive integer, and we are going to consider the divisor b is equal to 4 over here. Now by Euclid's division algorithm, why we have considered 4? Because we know that here they are asking for divisible by 8. So since 4 is a factor of 8, so here we have considered b as 4. Now by Euclid's division algorithm, we are going to consider, because the more value of b you will take, the more you have to prove, like, because the possible remainders will be more. Okay, so that's why if we take 4, then we can prove this one. So now a will be 4q plus r, where 0 less than equal to r less than b, that is 4. Okay, so the possible remainders will be 0, 1, 2, 3. Now a equal to 4q plus r means, now replace the r value over here. So 4q plus 0, that is 4q, or 4q plus 1, or 4q plus 2, or 4q plus 3. Now where q is some integer. Now here they are asking, we have to prove that n square minus 1 is divisible by 8. Okay, so now any odd positive integer n can be written, because if here n they have specified that odd positive integer. So if you remember in the previous question, we have seen that odd positive integer can be represented as 4q plus 1 or 4q plus 3. That's why we have considered here the B as 4. Okay. So now any odd positive integer can be written as 4q plus 1 and 4q plus 3 form. Now if we take the case number 1, that is 4q plus 1 as n, then n square minus 1 will be 4q plus 1 whole square minus 1. Now apply a plus b whole square formula over here. So that is 4q whole square, that is 16q square, plus 2 into 4q into 1, that is 8q, plus 1 square, that is 1, minus 1. So it is coming 16q square plus 8q. Okay, now if you take 8 as common over here, 8q also you can take common, then it will be 2q plus 1. So we can clearly see that this is a multiple of 8. So in turn we can say that it is divisible by 8. Now let us take the case number 2. So here n is equal to, we are going to consider 4q plus 3. So if n is equal to 4q plus 3, then n square minus 1 will be 4q plus 3 whole square minus 1. So that again we have to apply a plus b whole square formula. So 4q whole square, that is 16q square, plus 2 into 4q into 3, that is 24q, plus 3 square, that is 9, minus 1. So which is coming 16q square plus 24q plus 8. Now if you take common as 8 over here, then 2q square plus 3q plus 1. So you can clearly see that this is a multiple of 8. So that means it is divisible by 8. Now let us take another problem. Prove that if x and y are odd positive integers, then x square plus y square is even but not divisible by 4. Okay. So in this case, we are going to consider x equal to 2m plus 1 and y equal to 2n plus 1. Why? Because x is given as odd positive integers. So we know that if we multiply any number with 2, that number is going to be even number, and if we add 1 to it, then it will always be odd. So that's why whatever be the value of n and n, it is if n and n is a positive one, then always it will be the x and y will be odd positive integers. So now x square plus y square will be equal to 2m plus 1 whole square plus 2n plus 1 whole square. Okay, where we have considered m and n are the positive integers. Now apply a plus b whole square over here. So that is 2m whole square, that is 4m square, plus 2 into 2m into 1, that is 4m, plus 1 square, that is 1. Again 2n whole square is 4n square, plus 2 into 2n into 1, that is 4n, plus 1 square, that is 1. Now let us group this 4m square plus 4n square. Similarly group that 4m and 4n and group 1 plus 1, that will become 2. Now let us take common as 4. So m square plus n square plus m plus n plus 2. So m, we can represent it as q. So 4q plus 2. So where q is equal to m square plus n square plus m plus n. So now here we can see that 4q is even. So 4q plus 2, that is also going to be even over here. So x square plus y square, we can say that it is always be even. Now if you compare this, a equal to bq plus r, where divisor is here 4, then remainder is 2. Okay, so if we compare this, a equal to bq plus r, then bq plus r here is 4q plus 2. So divisor will be 4 and the remainder is 2. So since there is a remainder as 2, so that means it is not divisible by 4. Divisible by 4 means there should be no remainder, right? So since here we have a remainder, so that means it is not divisible by 4. So what we have proved that x square plus y square is even, but it is not divisible by 4. Now the next problem. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. So now let us consider a be any positive integer for the divisor 3. Then by Euclid's division lemma, it will be a equal to 3q plus r, where r is equal to 0, 1 or 2. Now, if we just replace the r value, then a will be 3q or 3q plus 1 or 3q plus 2. Now, if we consider case 1, that is when n equal to 3q, then n plus 2 will be 3q plus 2 and n plus 4 will be 3q plus 4. Now, if we take 4, if we divide 4 as 3 plus 1, then if we take 3 as common, then 3q plus 1 and our 1 will be outside. So now if we compare this with 3q plus r, here only n is divisible by 3, right? Because you can clearly see that n is equal to 3q, that means it is divisible by 3. But if you take n plus 2 is 3q plus 2. So it is not divisible by 2 because we have a remainder over here. Similarly, if we take n plus 4, there also we can see that 1 will be the remainder. So that's why it is not divisible by 3. So only in this case, n equal to 3q, that is only n is only divisible by 3. Now take case number 2. Because in this case, we have to consider, you have to prove that any of it will be divisible by 3, not all of them. Now, when n equal to 3q plus 1, then n plus 2 will be 3q plus 1 plus 2, that is 3q plus 3. Now, if you take 3 as common, then it will be 3 into q plus 1. So, that means we can write it as 3m, where m equal to q plus 1. So, now n we got 3q plus 1, n plus 2 is in the form of 3m. Now let's check n plus 4. N plus 4 will be 3q plus 1 plus 4. So that is equal to 3q plus 5. Now we can replace this 5 as 3 plus 2. So that is going to be 3q plus 3. Now if you take common over here, then 3 into q plus 1 plus 2. Now replace this as m. So this is going to be 3m plus 2. So where m equal to q plus 1. Now if we compare this with 3q plus r, then we can clearly see that here n plus 2 is divisible by 3 because n is 3q plus 1 where 1 is the remainder. So that means it is not divisible by 3. Similarly, n plus 4 is we have a remainder as 2. So that's why it is not divisible by 3. But n plus 2 is equal to in terms of 3n. So that means it is divisible by 3. So in this case, n plus 2 is divisible by 3. Now we are going to consider case 3 where we are going to consider n equal to 3q plus 2. So n plus 2 will be 3q plus 2 plus 2, that is 3q plus 4. Now we will divide 4 is equal to 3 plus 1. So 3q plus 3 plus 1. So now take 3 as common, then it will be q plus 1 plus 1. So now replace this q plus 1 as m, so 3m plus 1. So where m is equal to q plus 1. Now let us take another one, that is n plus 4. So that is going to be 3q plus 2 plus 4, right? So because n is 3q plus 2, so 3q plus 6. Now if we take 3 as common, this is going to be q plus 2. So 3 into m. So where m is equal to q plus 2. Now we can clearly see that in this case, n is equal to 3q plus 2. That means 2 is the remainder, which indicates that n is not divisible by 3 because we have a remainder. For n plus 2, we have a remainder as 3m as 1 because it is 3m plus 1. So that means this is also not divisible by 3. Now for n plus 4, we got it as 3m. So that means it is completely divisible by 3. So in this case, n plus 4 is divisible by 3. Here there is a printing mistake. It should be n plus 4 is divisible by 3, not n plus 2. So while you are writing it in your copy, make sure you are correcting it in your copy. So hope this is clear to you. So that's all for today's video. If you have understood it, just put a thumbs up button so that I can understand that you liked the video. And if you have any comments or if you got stuck with any problem, you can always put that in the comment section. Then I will try to come up with a video for that. And if you like it, please share it with your friends. And don't forget to subscribe to my channel. Otherwise, we will not be able to get any notification for the upcoming videos. Okay. That's all for today. Thank you. Bye bye.